All right, IB seniors, today we're going to learn how to use identities to solve some problems. For today we're going to look at just the first two. This is off your formula sheet, which is, if you look in your folder, it's in there. It's also under student resources in your folder. You're going to need a copy of this because we use it all the time. You'll be able to use the full formula sheet during the test. All right, but anyway, this is under the trigonometry identity rules. We're going to use the first two today, and then tomorrow we'll talk about some of these here. So tan can be substituted with sine over cosine or vice versa. If you have sine over cosine, that is equal to tangent. And this is called the Pythagorean identity because it's very much like the Pythagorean theorem. Leg squared plus leg squared equals the hypotenuse squared. Remember, on a unit circle, the hypotenuse is 1. So really, you can kind of think of that as 1 square. And there, it's more obvious that it is the Pythagorean property. All right, here's a couple examples, and these are going to be brief examples here. Look at the IB video for a more thorough explanation of all this stuff here. All right, here you go. First example. Given cosine x equals -2/5 in quadrant 2. Remember, in quadrant 2, this is your negative positive quadrant. You want to find sine x and tan x. So we're going to do this one with the Pythagorean property first, but then I can show you how you can do a drawing as well. All right, so what we're going to do is write down the rule. Cosine squared plus sine squared. That's theta there, but it doesn't matter if it's theta or x. Cosine squared theta plus sine squared theta equals 1. All right, so what this means is some quantity squared plus some other quantity squared is equal to 1. We know the cosine is -2/5. We can plug that right in here. We don't know sine. So now keep in mind this expression and this here are the same thing. This one is kind of a shorthand notation where you don't have to bother with parentheses. But the idea is that the fraction is going to be squared. You're not squaring the angle, you're squaring the fraction. All right, so anyway, here you get 4/25. Square the top and the bottom. Remember, a negative number squared is no longer negative. All right, so you're going to subtract that from both sides. If 1 is the same as 25 over 25, and so when you subtract the 4/25, you can get sine squared theta equals 25 minus 4 is 21 over 25. Now you're going to square root. Now we know in this quadrant, even though we're doing the rule, you still got to be mindful of what the quadrant is. We know in this quadrant that sine is positive. Remember, the first number is cosine, the second one is sine. So I'm looking for, normally I would do plus or minus the square root of this here, right? When solving a squared problem. But we know it's not going to be minus. It's only going to be positive. In quadrant 2, you have to be positive. You should be positive anyway in life, right? All right, and then this is the same thing as square root of 21 over square root of 25, which is 5, end of story. All right, I don't know if y'all can see that a little bit better there. All right, so now we've got to find tangent. That was all part A, right? Finding sine. But look, now we know this. For part B, that was part A. For part B, we know that tangent, I always start by writing down the rule, is equal to sine over cosine. All right, so we know that sine is square root of 21 over 5. We know that cosine is -2 over 5. Now, if you wanted to, you could flip this upside down and multiply and cancel out the 5s, but you could also do this little trick. If the 5s are in the same position, when you flip this one, remember dividing by a fraction, don't ask why, flip the bottom and multiply. If you were to flip this one, the 5s would cancel, wouldn't they? You can cancel them in this position here. And you get 21 over 2. Let's just put the negative off to the side. And that is using both the Pythagorean identity and the tangent identity. All right, let me show you one more. I'll make these too long. They're impossibly hard to load up on YouTube, so I'm trying to keep them really short. All right, here's one. When they give you tangent, this one will do with drawing the picture. I should have done the last one, but this one, it's kind of hard to come up with a relationship here. Sine over cosine does equal tangent, but you're going to have two unknowns. So this one, it's best to go ahead and draw the picture and use the actual diagram. So quadrant 3 is over here. So we know we have some kind of hypotenuse in quadrant 3. So we have the angle is rotated to quadrant 3. And so we have some point over here. Well, to get to that point, remember the idea in math when you're naming the location of a point is to go over first and then up or down. So I'm going to go over and then down. And that creates a nice little triangle. Over and down. Don't go down first. All right, so there's your right triangle. Tangent is square root of 3. Well, square root of 3 is the same as square root of 3 over 1. We also know that tangent is opposite over hypotenuse. Opposite over adjacent. So that's the opposite. And that can be the adjacent. So here's my reference angle. The opposite is square root of 3. The adjacent is 1. Now you notice something's wrong with those numbers because any point in this quadrant really needs to have a negative x and a negative y, therefore a negative cosine and a negative sine. So really, it's not square root of 3, it's square root of 1. It's negative square root of 3 and negative 1. It simplifies, this divided by this simplifies to a positive square root of 3. But the original numbers must have been that. Anyway, so what you want to find is this here, which you can find from the Pythagorean theorem, right? So now using the basic Pythagorean theorem on this triangle, you don't need the negative there, it's going to disappear anyway, right? Remember, when you square a negative, they're gone. So whenever you're doing the Pythagorean theorem, just forget about the negatives to begin with. So that'll give you 3 plus 1 is 4. Well, this would be hypotenuse square. So the hypotenuse, let me back up here, getting kind of sloppy. So if the hypotenuse squared is 4, then the hypotenuse itself must be 2. So we know that number there. All right, so we have the opposite here. We have the adjacent over here. Adjacent means next to. Opposite this angle is over here. Adjacent, touching the angle, is right here. And then this is the hypotenuse. So we know that sine, going back to answer the questions here, sine x is opposite over hypotenuse, which is going to be negative square root of 3 over 2. And for b, cosine x, we know that cosine is adjacent over hypotenuse, which is negative 1 over 2. By the way, notice that these numbers could have been found from the unit circle. On the unit circle, basically we're talking about this position right here, right? Negative 1 over square root of 2, and then negative square root of 3 over 2. All right, that's it for today. Again, watch the IB videos. They do it a little bit differently, but that's good that you learn 2 different ways of doing the problems. And then check back tomorrow where we're going to work on using the double angles. And double angles, even though they look more complicated, are really sort of easy. They're much easier than they appear. See y'all tomorrow. Bye.